friends, I am Dr. Marathe. Today we will discuss about the glycolytic pathway. In short, this is known as glycolysis. Metabolic EM pathway. Now glycolysis is nothing but what? A series of reactions which are enzymatic reactions through which the glucose is catabolized into pyruvate or lactate. This pathway was first elucidated by Emden and Mayrhof in 1940. So in the honor of them, this name is given EM pathway, that is Emden-Mayrhof pathway. So this word glycolysis, it's a Greek word. The meaning is glyco means glucose and lysis is nothing but what? Dissolution. Means in short, the pathway or the mechanism by which glucose it is dissolved, means catabolized or oxidized through the series of enzymatic reactions either in a pyruvate or lactate. That's why it is called as glycolysis. Now let us talk about the saline features of glycolysis. What are the saline features of glycolysis? Glycolysis, it is the most common reaction, most common pathway in all types of reactions, all types of cells, reactions. This is the most common way of ATP generation inside the cell. This is the first saline feature of this glycolysis. Second, this pathway can be operated aerobically, means in presence of oxygen, and it can be operated anaerobically, means in absence of oxygen. When it is catabolized in presence of oxygen, then first of all it is converted into pyruvate, and that pyruvate is finally converted into carbon dioxide and water. But if oxygen is not available, if the glycolysis occurs in absence of oxygen, then this is converted into the product is known as lactate. So anaerobically, glucose is catabolized to lactate, and aerobically, this glucose it is catabolized to complete oxidation of glucose is what? Carbon dioxide and water. This is the second saline feature of glycolysis. Next, glycolysis, it occurs inside the cytosol of every cell. Cytosol means cytoplasm of every cell. And the further oxidation means after conversion of glucose into pyruvic acid aerobically, the further oxidation that occurs inside the mitochondria. This is the most common, as it is divided into 3 phases. First is known as energy generation phase. Energy. This is known as energy utilization phase. Or we can call it as the energy investment phase. Or it is also called as a priming phase. This is the first phase of glycolysis. Second phase is known as splitting phase. Third phase is called as energy generation phase. So I'll repeat it again. Glycolysis, the whole process of glycolysis, it is divided into 3 steps or 3 phases. And these 3 phases are, first is the energy utilization phase or energy investment phase, that is also called as priming phase. Second is called as splitting phase, or it is also called as a cleavage phase. And third is energy generation phase. Now there are near about 9 to 10 reactions in the whole glycolysis. So that reactions or those enzymatic reactions that we will see one by one. So let us start how the glycolysis occurs, how the glucose it is catabolized into either a pyruvic acid or lactic acid. Okay, let us start with the first, that is glucose. Structure of glucose: C6H12O6. It contains 6 carbon atoms. This is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4, this is carbon number 5, this is carbon number 6. Now this is a structure of glucose, we call it as alpha B glucose. Now in the first reaction of glycolysis, the first enzyme works. That enzyme is known as hexokinase. As it acts on a hexo sugar, glucose is a hexo sugar, that's why this is called as hexokinase. This is the phosphorylation reaction. As the name is kinase, so this is phosphorylation reaction. In this case, ATP, it is hydrolyzed to ADP. One phosphate group is removed, and that phosphate group causes the phosphorylation of glucose. Now the structure becomes H, OH, H. Now, see, you can see the phosphate group which is denoted by ATP. It is linked with the carbon number 6 of glucose, and that's why it becomes glucose 6 phosphate. Glucose 6 phosphate. Now this glucose 6 phosphate In the next reaction, it gets isomerized. Isomerized means isomerization of this glucose 6-phosphate occurs. Now glucose, all of you know that it is an aldose sugar. This aldose sugar is converted to ketose sugar. So the enzyme is phosphoglucoisomerase. This is a complete one name, phosphoglucoisomerase. So this aldose sugar is converted to ketose sugar. So that is CH2OH CH2OPH. Now the number of carbon remains same, only the structure becomes different. So pyridine ring, it is converted into a furan ring. The number of carbon remains same. So you can label it as carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and this is carbon number 6. Now this is called as fructose 6-phosphate. Fructose 6-phosphate. So this fructose 6-phosphate in the next reaction undergoes second phosphorylation. And the enzyme is PFK. The long form of PFK is phosphofructokinase. Now this phosphofructokinase hydrolyzes one more ATP. This ATP is converted to ADP. That means one phosphate group is removed. That phosphate group is linked to carbon number 1. So this structure becomes CH2OP OH CH2 already one P is there, H. Now this fructose, another phosphate group is attached. So its name becomes fructose 1,6-biphosphate. Fructose 1,6-biphosphate. Now, as we already discussed, there are 3 phases of glycolysis. First one is the energy investment phase, second is known as splitting phase, and third one is the energy generation phase. So from this step, that means starting with the alpha D glucose till fructose 1,6-biphosphate and one more. Up to this, from alpha D glucose to fructose 1,6-biphosphate, the first phase of the glycolysis gets completed. That is called as the energy investment phase. Now the second phase starts. It is a single reaction phase called as splitting phase. Now see, this 6-carbon sugar, it is splitted in this manner. Means ring gets opened. This 6-carbon ring, it is converted into 2 3-carbon compounds. So from 1, 2 and 3, carbon number 1, carbon number 2 and carbon number 3, one compound is formed, CH2OP, then C-O and CH2OP, CH2OH. This is known as DHAP, dihydroxyacetone phosphate. Okay, and from carbon number 4, 5 and 6, another 3 carbon compound is formed. That 3 carbon compound is known as glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate. Okay. Now this time the enzyme, it is known as fructose 1,6-biphosphate aldolase. It is known as fructose 1,6-biphosphate aldolase, which is responsible for the splitting of this ring, cleavage of this ring, and 3 carbon compounds are formed. So it becomes C double O H H C O H and CH2OP. So after cleavage, after splitting of this 6 carbon fructose 1,6-biphosphate, 3 carbon compounds are formed. One is called as DHAP, dihydroxyacetone phosphate, and second is known as G3P, glyceraldehyde 3-phosphate. This both means DHAP and G3P. These are nothing but what? These are the isomers of each other. So these are interconvertible. These are interconvertible. But the next enzyme in the glycolysis is called as triose phosphate isomerase. Triose phosphate isomerase that converts this DHAP into again another molecule of G3P. Okay, already one G3P is formed. This triose phosphate isomerase isomerizes this DHAP into another molecule of G3P. So total 2 molecules of glyceraldehyde 3-phosphate these are formed. Because the next enzyme in the glycolysis that acts on only G3P, glyceraldehyde 3-phosphate, and the name of the enzyme is glyceraldehyde 3-phosphate dehydrogenase. What is its name? Glyceraldehyde 3-phosphate dehydrogenase. This is the only oxidation reaction in glycolysis. And all of you know that dehydrogenase means removal of 2 hydrogen atoms. So these 2 hydrogen atoms were removed from the glyceraldehyde 3-phosphate. Acceptor is NAD plus. After accepting 2 hydrogen atoms from the structure, it gets reduced to NADH plus H plus. Simultaneously, there is an addition of inorganic phosphate to this structure, glyceraldehyde 3-phosphate. And whatever the structure is formed, that structure is called as 1,3-biphosphoglycerate. That is called as 1,3-biphosphogyl. C double O P already H C O H and structure is CH2OP. This is known as glyceraldehyde 1,3-biphosphate. That's it. Glyceraldehyde 1,3-biphosphate. This is the first, as I said, this is the first dehydrogenation reaction, means oxidation reaction, and this is the alone dehydration oxidation reaction in the whole glycolytic pathway. And the enzyme is glyceraldehyde 3-phosphate dehydrogenase. So it is converted into glyceraldehyde 3-phosphate, the glyceraldehyde 1,3-biphosphoglycerate. Sorry, this is 1,3-biphosphoglycerate. 1,3-biphosphoglycerate means from the oxidation by G3P dehydrogenase, this G3P is converted into 1,3-biphospoglycerate. Two phosphate groups are attached to this structure. It is one on carbon number 1 and carbon number 3 of this structure. And in the subsequent reaction, another enzyme works. That enzyme is called as 1,3-biphospoglycerate kinase. 1,3-biphospoglycerate kinase. So this is the first energy generation phase. As I said, first phase is energy investment phase, second phase is splitting phase, and third phase starts from this, that is called as the energy generation phase. So in this case, one ATP is formed from ADP. That high energy phosphate group, it is dominated by 1,3-biphospoglycerate. The structure becomes COOH after removal of this high energy phosphate group, then HCOH and CH2OP. So ultimately, after removal of the first means phosphate group from the first carbon, then only the phosphate group on the third carbon remains, and that's why this is known as 3-PGA. It is called as a 3-phosphoglycerate or glyceric acid. Next reaction is simply a transfer of phosphate group from carbon number 3 to carbon number 2. Okay, so structure becomes COH as it is, then HCOP, okay, and CH2OH. Now this is called as 2-PGA, means 2-phosphoglycerate. As there is a shifting of phosphate group which was already on carbon number 3, it is shifted to carbon number 2. That's why this is called as 2-phosphoglycerate or 2-phosphoglyceric acid. The enzyme is phosphoglyceromutase, which shifts the carbon phosphate from the carbon number 3 to carbon number 2. Next enzyme which acts on 2-phosphoglycerate, that is called as phosphoglycerate kinase. Means this is the next enzyme after 2-phosphoglycerate. Next enzyme which acts on 2-phosphoglycerate, it is called as an enolase. Okay. Now in this case, what happens is the removal of water molecule. The structure becomes what? This becomes COOH. Now this hydrogen, this side of the group, it forms a water molecule. It is removed in the form of water molecule. So what it means? COOH, COP, double bond CH2. This is the highest energy containing compound known as PEP. So phosphoenol pyruvate. as the intermediate product produced, it is enolic compound. That's why it's called as a phosphoenol pyruvate. And the last phase or last reaction, which is the second energy generating reaction, in which ADP is converted to ATP by the enzyme known as pyruvate kinase. Pyruvate kinase. This pyruvate kinase converts this phosphoenol pyruvate into pyruvate. So COOH, C double bond O. So hydrolytic reaction occurs. So this high energy phosphate group, it is transferred to ADP, that becomes ATP. So COOH, C double bond O and CH3. This is the end product of glycolysis. When glycolysis, it is operated under aerobic condition. When oxygen is present, this pyruvate through the one intermediate called as acetyl-CoA enters into the TCA cycle. Through TCA cycle and electron transport chain, there is a generation of carbon dioxide and water. So we can say under aerobic condition, this glucose, one glucose molecule, it is catabolized into carbon dioxide and water after complete combustion or oxidation. Now, one more thing is what? Through energy investment phase, this is converted into fructose 1,6 biphosphate. But after cleavage, this is generation of two molecules, means one glycerol 3 phosphate, another DHAP. But next enzyme that acts on only glycerol 3 phosphate, not on a DHAP. So that's why this DHAP is again isomerized to another molecule of G3P. So from this state, every compound produced, it is twice. That means two molecules. So two molecules of G3P, two molecules of 1,3 biphosphoglycerate, two molecules of 3-phosphoglycerate, two molecules of 2-phosphoglycerate, two molecules of phosphoenol pyruvate, and two molecules of pyruvate. That means one glucose molecule, when it is catabolized through glycolytic pathway, it generates two pyruvic acid molecules. So this is the glycolytic pathway or glycolysis. So after that, we must think about what is the net gain of energy after conversion of glucose into two molecules of pyruvic acid. So through the energy investment phase, two ATPs, this one and this one, two ATP molecules are used, invested, that means they are used. Okay, but in the third phase, that is called as the energy generation phase, which starts from 1,3 biphosphoglycerate to pyruvate. Here, two molecules of ATP they are produced here, and two molecules of ATP they are produced here. Means total 4 molecules of ATPs they are produced, means 4. And how many are utilized? 2. So you can simply say after every glycolytic cycle there is a generation of 2 molecules of ATP by substrate level phosphorylation. And if you add up the oxidative phosphorylation, that is formation of this reduced NADH plus H plus. When this reduced NADH plus H plus donates the electron to electron transport chain, it generates 3 ATPs. Again, there are 2 molecules of these. So one molecule will generate 3 ATPs. So 2 molecules ultimately will generate 6 ATPs. So if you consider substrate level phosphorylation as well as oxidative phosphorylation, then after complete oxidation, after glycolytic reaction, this glucose, when it is converted to pyruvic acid, it forms 8 molecules of ATPs by substrate level phosphorylation and by oxidative phosphorylation. This is what about the glycolytic reactions or glycolysis. I hope you must have understood this pathway. Thank you very much.